Welcome to another dev stream, a daily dev stream. I'm always a little worried. I'm just going to annoy some people on Twitter. I feel like on Twitter, posting a daily live stream, well, it might not have the highest degree of substance relative to tweets, which may be a little bit more tailored, but that's what I'm doing, for better or worse. But welcome. Today we begin with a little bit of controversy. People saying the download button works or download button doesn't work. So I don't know what's going on there. Resolve GLTF. It looks like there's a download GLTF function. GLTF is a 3D file format. Imposter, good morning. Welcome. Good to see you. But it's not working in prod. Download. I don't know. It looks like I'm trying to think of where the download menu might be. Oh, this project's too big. Oh no. Header dropdown? Maybe. No. Editor nav? What did you break? Apparently, this guy spent some time fixing our GLTF downloader. And he was like, on a technicality, this is a better implementation. And I'm like, what are you talking about? And yeah, it's like, it's confusing. He like rewrote the implementation, but it's unclear if they had to. It's like, it technically used a hook. And the only reason it could be considered valid is because the downloader is broken. So I mainly don't like this PR because it changes so much stuff. But yeah, when you click on this, it says error downloading 3D model, no 3D object found. Run snippet before downloading 3D model. I think you have to have the 3D view open. Yeah, okay. All right, that clarifies it. So you have to have the 3D view open. And if we go to a GLTF viewer, let's see. Is it going to load our little push button? Yeah, okay. I don't think this fixes anything. The 3D download works. However, the 3D view must be open. So we really have an issue in that the error message doesn't tell you to open the 3D viewer. Dr. Sensor is working. Oh, this is so small. On a 3D download without a 3JS ref. All right. Well, that settles the controversy, I think. Not a huge fan of a PR that does nothing but refactors code and then claims a bounty. Yeah, I don't know about that. Let's see. Let's go to our issues here. I should do that using Sonnet. Probably could just fix the error. I was going to do it really quickly. I'm going to create an issue. Fix 3D if 3D download fails because 3D viewer isn't open, show an appropriate error. A more appropriate error. Yeah, if there isn't a 3D viewer ref, we should tell the user to open the 3D viewer. You know, in an ideal case, we would actually just like open it for them. We certainly can do that. Oh, but yeah. A lot of people are filing. All right, let's see if this is valid. The shipping form is not responsive. Fine. I don't like web development issues because people create bugs all the time. Like people should just fix them. I don't know. People wait for bounties on them. I'm like, we're gonna create so many bugs while waiting for other things. I'm like, we're not in an optimization stage, but I get it. Whatever. Not that I need the money just to get my name on the contributor list. Yeah, I mean that's why most people should do it. You don't have to claim the bounties. The bounties have started to discourage people who don't want it, but yeah. Anyway, I don't know. What can I do? What is a person to do? I think I upset the maintainer, the open source maintainer of the free routing project. I'm not sure, but he hasn't done any. He hasn't done. He hasn't done any PRs or answered me on GitHub in a little bit. So, and I think I miffed him because we run our own free routing servers, and I think he wanted to run them. So it's just I don't know. I'm projecting a little bit, but I do suspect that is the thing. Holiday season contribution list. Who's been naughty or nice? Anyway, I wrote a little bit about. Sorry, I'm like. I wrote a little bit about an algorithm yesterday for doing pathfinding that uses repeated patterns. So you can see there's two patterns here. And they can be reflected, and it applies these patterns to do auto routing. And why I like this is it's a very good sparse space problem. Our other auto router is a little bit better at dense problems because it can like move in little increments. But this one is really good for sparse problems because there's a fixed cost to computing an intersection. So, Steve, do you need math for this? I've been learning development and seen videos saying you need linear algebra calculus. Is this true? For auto routing, absolutely. You should build an auto router. We have a website, autorouting.com, and it has a bunch of data sets. And we're doing benchmarking. We have a bunch of things that run these, but basically, this is a keyboard. It's kind of hard to tell, but this is a keyboard. And these keys need to be connected to the computer, the microcontroller. And so, yeah, we basically need more auto routers. It sounds like linear algebra wouldn't be relevant, but it is. A lot of math is relevant. You could even use graph theory. I personally, I think graph theory is important, but I don't love a lot of graph theory solutions because for this particular problem, I think you want to slowly build your graph. You don't want to have the full graph at the beginning. And a lot of graph theory problems, they like to, as input, you give all the data. And yeah, it just doesn't work super well. Would he charge you for servers, the free routing guy? I don't know, maybe. It seemed like he was kind of leaning in that direction. And I would have done that, but I just have like low levels of trust for anybody running my infrastructure. Because it took me a month or two to get our free routing server stable. So our status page shows how stable our auto routing servers have gotten. And we run an auto routing job every 10 minutes. So it sounds dumb, because one, this isn't that high. We could make this higher too. We got to approximately 99, and I was like, that's good enough. Because you can increase it. I would just need to have like a second server, because it's I think it's single server right now. But and anyway, what's 99% of a month? It goes down for 99% of, oh, right. What's 1% of a month, if that's the downtime? So 7.3 hours evenly distributed over a month. So 10 minutes. It's not the worst thing. It's definitely not pleasant, but it's not the worst thing. It could be better. It could be better. But anyway, it took it. My point is, it took a while because there's like memory issues and all these problems with auto routers. So to kind of stabilize a very unstable thing was tricky. And I just didn't think, I don't want to bet our software, which is so dependent on auto routing, on somebody else's servers. Are you using Amazon servers? No. Where's your auto routing server? We use Fly. We use Fly and auto scaling micro VMs. And so that's part of the reason why it's, there's two reasons why it's at 99 and not at 99.99. And it really comes down to the foundation software is a little bit how do you describe it? It's a little bit, it breaks. Like, so let's say every 50 auto routing jobs, it breaks. So you need to recover from that. And I think we recover very quickly, but the underlying software breaks. And then, so we boot up a second server, and Fly can do that very quick. TS Circuit is a VM, isn't it? We use a Docker container for the free routing server, but we run distributed. We run in a lot of different ways. I would say that we actually usually don't use Docker containers. But for scaling a Java app, a Docker container seemed like a very good fit. The maintainer runs a server on Azure, and it went down for me a couple times. I didn't give him much time to try to fix it. So anyway, I feel a little bit bad. So I don't know. I'm reaching out to him and seeing what's going on. It's not like he's responding to other people. I think he's just got a lot going on in his life, and I'm just not that high priority. Anyway, I wrote an algorithm about the recursive path pattern pathfinder, which I want to try in an auto routing context. And I know from building the other auto routers how to make this a lot faster. So if we look around here, it's doing a lot of calculations, finding paths. And how this works is it just recursively applies a pattern. So each time a line segment has an intersection, it just tries to do another pattern, and then it repeats that for each segment that has an intersection. So it's a very good sparse. I think I thought about this a long time. How to do a scale invariant optimal pathfinding problem, where it scales, the complexity scales as you have more obstacles. And I think this is probably optimal for a truly sparse problem, which PCBs aren't truly sparse. So I'm not saying it's going to be optimal, but I think it's optimal for a truly sparse problem. If you just had like random squares all over, I think something like this would be optimal. There's a couple ways to make it better. For example, you can optimize the patterns, right? So I'm saying within the space of any, if you selected the right patterns, you could get it to be optimal. And then there's one other thing that I didn't do that I think might improve, might make it more optimal, and that's if you did smaller segments. So you didn't replace an entire segment. You replaced it whatever region it's intersecting. So probably doesn't make much sense, but my point is, I think it's a very, very good sparse algorithm, and I love sparse algorithms because often small PCBs are sparse. Larger PCBs tend to be dense, and so you would want to bring in a different algorithm, but smaller ones tend to be sparse. You could use a sparse problem until you had more than 300 traces, and then after you have 300, maybe you have 300 to 5,000, you would switch to a dense. So different algorithms for different use cases, maybe. The most I think probably the thing people get wrong, and what I got wrong last night until I, hit myself on the head and realized this was not the right way to do it, is I started writing a sort of recursive implementation because it is like a very naturally recursive problem. But this is a big dumb thing to do. Whenever you can score the quality of something, you want to use A star. A star is incredible. I feel like because of the name or something, I never gave A star a lot of credit. I was like, oh yeah, it's like a thing. There's lots of options, but no, A star is so freaking good. You always want to use it. So what we're gonna do is write a star implementation that can right now you're seeing a single layer, single iteration of the auto router, but it disappears. The path disappears. It can no longer route when it needs to go 2 iterations, right? So actually, it's kind of hard to make it fail, but yeah, it can't route around this because it's not doing any recursion or anything like that. So we're going to write an implementation that handles that. We could write the recursive implementation for fun, but honestly, like recursive implementations, they're almost bad for you. They almost make you think the wrong way. Shiba, what up? Welcome. Good to see you. Welcome to the Oasis. This is such a distraction. I have so many important things to do because I think I have, let's see, there's 15 days, 16 days left in the month, 17. So I need 14 days to get a board shipped to me. So I only have 3 days to order whatever boards I'm going to order for my monthly update. So this is a distraction right now, but I'm indulging myself. You gotta live, you know what I mean? Oof. Oh, strong. Shibo coming in hot with some of these prompt benchmarks recently. Big fan. I have a call today, and I put one of a screenshot of the prompt benchmarks on the slides, so maybe somebody will go, oh, that's exactly what I want. Is there going to be a repo where people develop autorouters, test them, and publish them? Yes. I feel a bit bad about this because that's what TS circuit / autorouting was supposed to be, but it hasn't gone the way I'd like. So this is a new repo, this recursive pattern autorouter, which again will not really be recursive, but it's easiest to think of as a recursive thing, but we're not going to implement it as a recursive algorithm. Yeah, after I publish this repo, you'll probably have like the simplest version of an autorouting repo, and it'll include, this uses our standard simple route JSON format. So you'll be able to play with your autorouter like this. You can do an interactive playing, and then we'll also have some SVG snapshot tests, some debugging SVG tests. So basically, I'm going to try to make a really good repo for a single algorithm, and then we'll see if we can scale that up. I might have a mono repo where we can develop algorithms, or more likely, I'll just say, hey, do it. You can do it on your own repos, and if it's good, if you do well on the benchmarks, we can integrate into the broader TS circuit, or we can just link to you and stuff like that, and show your name on the leaderboards or whatever. Because I want to have unity as a community, and to do that, we generally want to be in the TS circuit org, but I also it's kind of like snippets. There's a lot of chaotic snippets on snippets, and I want people to be able to express themselves, and not have to get a code review. Sometimes doing something other than you need to do helps. I agree. I want to know what the experience would be for somebody developing an autorouter. Well, you're getting it today because that's what I'm doing. That's what I'm here to do. I went to sleep working on this problem, and I actually got a little sad. I was like, am I gonna be able to work on this tomorrow morning? You know, because I'm doing a live stream. Maybe I'll be doing reviews, but there are very few reviews this morning, so I get to do what I really wanted, which is work on this autorouter. So I was thinking about this a lot last night. If I wanted to change how I do A star, and I think like as far as like having a class, yeah, because so let's just create an A star class, or maybe generalized A star is what we call it in a different project. It really does lend itself to a class. So even though classes are sort of maybe not the best taste, I'm gonna use it, and they can also destroy some optimizations. But the thing about A star is it runs in iterations and it has partial states. And when you have partial states, when you don't just have input output, it feels a little bit nicer to have a class to help structure your thought process. The restream bot is skipping some comments, it looks like. That's disappointing. I don't know why the restream bot would skip comments. I know it skips links. So if you're posting links, that's tough. But I will. Oh, nice. Rashab found out. Sorry, I guess I'm looking at the Discord for the first time. Nice find at Rashab. Rashab took a look into this weird issue we were seeing where, by the way, Shibo, this is a really funny circuit. I definitely want to include this on my update this month. Let me see if I can make this bigger. So Shibo has been routing LEDs. The chaotic energy on this one is real. Anyway, this says win in LEDs, which I love. And the auto router kind of went crazy. And what's cool about this is actually the TS circuit auto router, which the TS circuit auto router right now looks pretty punk. No, actually, no. This is the cloud auto router. Now that I think about it, it has diagonal traces. So this is, wow, that's crazy. Anyway, very cool little circuit. Yeah, can't wait to put that to the test. I was thinking about LEDs and how bright they are, and I realized we need to for me to make that board, you can't just connect that thing to USB-C. The LEDs, it'll either like blow out the USB-C port, or the LEDs will be super bright. So you'll need some kind of way to control the current. There's a lot of ways to do that. It's not the most complicated like design or anything, but yeah. You should make a TS circuit sound like that. Put it behind me in stream. Abso-friggin-lutely. Yeah, Shiba made it so it works for any letter. So you can use any letter, and you can put in any letters you want. So yeah, I mean, we'll make a whole friggin' website for people to just make a custom LED sign. Why not? So in our old auto routing repo, we have this generalized A-star auto router. There's a bunch of things I like about it. There's a couple things I want to change as well. But I've looked at this so much, I kind of like, sometimes there's files that you look at like every line and you just know how it works. So I guess there's like a little bit of extra stuff. I'm just looking through this, but the main functions you need for an A star autorouter are compute G for a node, which can be anything. A node can be anything, right? So it could be a pattern. You could say compute G. Yeah, so compute G, compute the cost of the path, and then compute H, which is how much has this path already costed. So G and H, and as long as you have G and H, you basically have these two functions, these two custom functions. As long as you have a definition for a node, compute G and compute H, you basically have an A star. You have the setup for A star. So that's what we're going to do. Compute G. It's going to take a node. I'm not sure what a node is yet. G, node. And then, why is it taking neighbor? I think this is the distance between two things. Is that right? We can look up some formalizations of this rather than my junk code. A star definition. A star is a graph traversal and pathfinding algorithm. Blah, blah, blah. Oh, who is it created by? The Shaky Project. A mobile robot that could plan its own actions. Holy moly, that's so old. Look at that. It's got a server rack on there. I love it. Yeah, so it selects the path that minimizes Gn plus Hn. H is a heuristic, and G is the cost of the path from the start node to N. Okay, so this is a little bit harder than I thought because we always have a path to the end. Is that true? We always have a path to the end. Yeah, we always have a path to the end. Okay, this will be slightly harder to apply than I thought. Let's see. We can figure it out. I think the percentage complete is going to be the score, basically. Is that right? I think that's about right. Something like that. Anyway, compute G. So this computes the cost of the path or the H is the heuristic. That's the distance remaining. Yeah, it's kind of interesting. Compute G. What does this actually take in this case? It's really, compute G is the number of segments that are complete. That's your score. I'm going to have to think about that one a little bit. We'll think about it as it comes up. Compute H is the distance remaining. So these are basically inverses of each other. So you can incorporate, and people do this, like when they're pathfinding, you can incorporate measures of complexity and stuff like that. This is where you can throw a penalty for how expensive your path is. So cost of the path so far. Yeah, node is kind of confusing me here. Yeah, this is very interesting. Node, what will the node be? Yeah, what is in a node? Tell me about it. In this context, I'm not sure. In a normal context, a node is just a point you're exploring. So like in a normal A star algorithm, you have your point, and then you have nodes you're exploring, right? So you're basically traversing a graph. So that's like, so normally, okay, yeah, we could do. It'll help me to do a somewhat full formalization. Okay, so let's say the length of this is 2, and let's say this is like 4. It's funny, people watch animations of A star, and they're like, oh, I like the path it took, but how did it actually pick that path? And then we'll throw in a obstacle here. So in this case, 4 is h. When you compute h, you're going to compute 4, and 2 is compute g. So a node, that's how it works. A node is just the paths you're exploring. And compute h doesn't know about obstacles, but compute g does, because compute g is a path that's already been created. It's stuff that you've already explored. And how A star works is for every possible path you're allowed that is available to you, you sort of pre-compute. You compute this, and then you select the one that looks most promising. So that's it. Yeah, node in an edge. Yeah, something like that. I think what I've done in the past is said, going real deep here. Let's say this is A, this is B, this is C. And let's say that there's an existing, I don't know why you use that arrow, but sure. Let's say there's an existing path over here called, okay, whatever. I don't know why I drew it like that. I'm not going to look into it. If there's an existing one here, what you typically would do in this compute G function is you would say, is the cost of B, or compute G of B plus path length, something like that. And so you can cache, so compute G C is equal to compute G B plus path length BC. And so because this is pre-computed and you store this, a lot of times you would store it on B, so you would just say B.G. You only have to compute the path length here, and so it goes faster. But how do you apply this to patterns is now our conundrum, which I didn't think about too much. I know it'll work. I know enough to know it'll work. I think I know enough to know it will work. But we just brain is processing. Okay. Yeah, it's a little bit tricky. Let's see if we can draw a representative problem. I'm 99% sure that this works. So, wow, it really wants to draw this curvy arrow. Oh, there we go. So let's do this. Let's make this dashed. And we're going to draw a couple variants here, like that. So let's assume we only have 3 patterns. I worked on a node graph thing, and it had its own thing. I didn't worry about this problem. Yeah, you can pull a lot of these graph algorithms off the shelf, but you pay a cost of constructing the graph and passing it into the algorithm. And so if you're trying to go really fast or do a lot of custom algorithms, you just stop paying that cost. And in this case, I don't think this one would translate well, because again, you have to compute. Usually, you have to compute the full graph. So I don't know, but I know some of my colleagues in different companies. What they do is mostly use off-the-shelf graph algorithms, and they get immediate, like, massive wins. But I do think you hit a wall because mostly because you just have to process so much data, and like you start to work on edge cases, which require processing more data, and it gets tough. So you kind of have to be pretty native to get it to work. Okay, so anyway, so let's say that we have a cost. I think this would be b.g. Or it's kind of weird. It's like abg. So each segment, let's call this a segment. So that's a segment. That's what we'll call those. And then this is a segment, and this has segment.h or h's, with different costs. So let's say the first one is 1 and the other 2 are 2. So those are the h's of each of those segments. So this one's 2, this one's 1, and this one's 2. I guess Excalidraw kind of has a little double click feature. That's not bad. Not bad. So I think a key optimization insight is some of these become that you can't do them. You can't travel the path. You can't traverse it. And so it doesn't ever become a neighbor. So you're not even evaluating the patterns where there is no path. Is that right? No. You have to evaluate them, actually. Yeah, you have to evaluate. Oh, yeah. No, these are all going to be conflicted in some way. That's right. Unless there's no segments. Okay. I'm slowly getting there. Okay. Yeah. Okay. This one. Okay. All right. We're getting somewhere. Okay. This segment G is 1. Hey, Sevi came over from Build Your CNC channel. Welcome. Man, his TS, unique title for stream. Yeah, I know. I'm not even doing TypeScript. What did I, just a man in his TypeScript? I don't know what I was thinking. I don't know what I'm doing, guys. Welcome, Rick H. Normally we do a little bit more coding, but I decided to wake up and choose violence, aka the algorithms. We're trying to make an auto-routing algorithm that uses recursive patterns. And before you say, "Hey, Steve," Steve's not my name, but if you're being derogatory, you might say that. Hey, Steve, why don't you just use a grid-based algorithm? To which I would say, have you even read the blog.autorouting.com blog? I think not. So this is probably, I have a hunch, this is the optimal scale invariant problem. Because no matter how you scale it, the cost of computation is only related to the number of obstacles. It's not related to distance at all. We worked on a different scale invariant problem that only did orthogonal things, but it too had some interesting properties with sparse data sets. So anyway, this is all to say, depth first or breadth first? Neither. A star. See, this is exactly what I'm talking about. I was talking about this at the beginning of the stream, but people go, they are too quickly reach for breadth first or depth first. A star is always it's a tunable algorithm. A star is always it's always the way you want to go, but it would be easier for me to do a breadth first or depth first. I already did it. I already did a depth first, or I believe it was depth first. Oh, whoops, wrong blog. I believe the original that we got working was depth first. So I actually scaled this up. I was able to do quite complicated paths. I think I have one at the top of this article, but fairly complex paths. But with the depth first search, you are wasting time evaluating solutions that lead to nowhere. So even in this case, this is a great this exact image is a great picture of like, why didn't it just go through here, right? Why didn't it take this little way here? And it's because it did a depth first search. So just as a coincidence, this algorithm tends to prefer patterns that go down, because the first pattern that it tries is a downward pattern. And so it tries all the bottom paths before it tries a top path. Am I teaching an Algorithms 101 class? Now you'll be called Steve. Sounds better. That's awesome. Glad I coined that. Asshole. Okay, sorry, Rick. Oh, no, A star. Oh, I thought you were like abbreviating a swear there. Now I understand. Okay, thanks, asshole. It's just a question. As long as you can figure out a good hint. Yes, the heuristic. Yeah. Yep. So my theory is that we have currently, let's see, 1, 2 different types of patterns, and I can add more. But my theory is that the heuristic is basically how many of these segments collided with an obstacle, and how much progress did you make. So was the path 66% complete, or whatever, and that's how you compute the heuristic, or G. The other thing I'll say about A star is there are a lot of optimizations people don't know about with A star that are fantastic, especially for sparse problems. There are little things you can tweak. You can multiply. I have a blog post somewhere, I hope, that talks about greedy. Let's see if we can find a greedy multiplier. Shit. All right. Yeah, unfortunately this is going to be buried, but somebody wrote a paper on game algorithms, on pathfinding for games, and they wrote about all these A-star optimizations, and we both stumbled upon, maybe it's somewhat formal, but there's a technique where you actually just multiply G, and you can multiply it in different ways such that your algorithm is a little bit more greedy about going deeper. So once it gets on a roll, it starts to find a path that's really good. It tends to just stay there. It tends to take it all the way to the end. So that can be bad in a dense context, but is actually great in a sparse context, because usually sparse context, you just need to, you don't really need to try these big things. You can kind of go deep, or something like that. And whenever you have a tunable parameter like that, you can take a real world data set like the ones we have on autorouting.com, and you can tune it. You can just say, hey, how well does this route keyboards and stuff like that? And we can do the same thing for the patterns. Another reason I really like this algorithm is I can just say, okay, let's find the optimal patterns. Yeah, there's a ton of really cool things we can do. I was also thinking of some, this is currently rotation invariant, so it doesn't matter if you rotate it 30 degrees, 90 degrees, it's not going to change how the algorithm works. But there are ways to make it more sensitive to rotation, such that it prefers straight lines, stuff like that, and that will make many PCB designers very happy. It'll make it a little bit easier to read. So there's so many ways to go from here, but let's start at the beginning. We really need this to be able to do long loopy paths. So let's get some long loopy paths working. Let's tarry no further and begin. Okay, so figuring out the shape of our node seems very important here. So we need some terminology to help us out. The name node is not helping us out. It really feels like you have the pattern, and I already have that name for the pattern, but that's not the pattern after it's been projected. So will have to come up with a better name, but there's a projected pattern, which is has segments. Okay. Do I have a segment type? I guess I don't have a segment type. Each segment has a start and an end. Okay. So that's our projected pattern. We're trying to reverse engineer, figure out what our node is going to be for this algorithm. So so a projected pattern has segments. Each segment not only has a start and end, but it has some kind of indication if there was an obstacle. So has intersection or collides. Has collision, let's say. Okay. And then when you have a projected pattern, you have the parent projected pattern. Yeah, we'll say projected pattern null. I think the root pattern will be null, so that's kind of a base case. And it can have a G. Let's say we're going to have to write like a more slow version of this that has a lot of extra variables that we store and compute. Did you remove the commas even in the object? Yeah, so for TypeScript interfaces, you can, for interfaces and types, you don't need the commas. It's like a TypeScript thing. I don't like semicolons. You know, I would have been okay with the language syntax if they had commas, but you know, I don't hate it. I'm a big believer in visual noise. So I don't like visual noise generally. So I think I would be anti-comma if somebody, you know, forced me to make a decision. There's a lot less reviews today, and I think I know why. I think we had our last hurrah earlier this week with reviews because I think a lot of people are college students who are now in school. So we'll see how many PRs we get in this new era. Especially like your first week at school, you're not going to be going nuts doing tons of PRs and whatnot. People are kind of putting me in a tough position too, because it's good. People who were contributing to TS Circuit, they learned a lot, and now their contributions are are very good. Very good, I would say. But for a while, it seems like people were just trying to like get their contribution scores as high as possible, so that they could kind of like get the sponsorship, and then put me in the very awkward position of being like, okay, because you're a mean boss too. You know, I mean, I don't think I'm a mean boss. What are people talking about? Why am I getting so many mentions? Settings responsive. Large width 1/2. So he's changing it from width 1/2 to large width 1/2, small width full. All right. All right. I don't want to. Why am I reviewing these? Other people, I need a code owner to just review like basic web dev stuff. What is this now? Is this the same thing? This is in the settings page. Now I'm confused. Did two people PR the same thing? I don't know what's going on. I give up. All right. Anything of interest here? Whoa, why did this get closed? Oh, somebody didn't like it. All right, we got a lot of new contributors coming in. But yeah. Okay, so people weren't getting it. It's kind of fun how people pay attention to issues they worked on and then give reviews to each other. It also kind of puts them in a little bit of an animal antagonistic state because they're like, "Hey, I wanted this PR." Oh, we got some AI description. That's cool. Oh yeah, lots of stuff to review. Footprint or string null, component description. If we have a footprint, we display the footprint. Okay. Who's he pinging? At Abza, this is good, but you need to have some kind of test that showcases what you fixed. That's about it. Just looked at it on stream. That's how I just prod people to come to the stream. Yeah, you just need assuming they somehow find out. Let's see. 05100. Yeah. All right. So if they do come back here, I think you just need to have a. First of all, this one doesn't make sense. Why make this change? Yeah, why change that one? Maybe just add a new. You could just add GP without removing GPIO. Yeah. So try to, I don't know, pull a readable netlist from circuit at tscircuit.com. It is downloadable from the download menu. Man, this project is like kind of the bane of my existence. I think nobody understands what this project is for, but we're trying to make readable netlists for AI, so it's got to be pretty good. Rohit, what's up? Welcome. I'm doing a couple PR reviews for just a wee bit. I don't think. Oh, did the migration get merged already? What's going on? Oh, added test case. I think it's good to merge now. Wait, I am confused. Oh, okay. I was looking at like a commit diff, not the PR diff. Okay, so we're adding to our database an expression generated, a lowercase version of the name. We've got all of this nice schema generation. So yeah, we're trying to make sure that these packages are identical when you request them from our ESM build registry. Okay, cool. Nice. Oh, I can't approve. Nice. At Imrishab. Got some good Postgres code there. Let's hope it doesn't crash the registry. Can't hang out for long, but if you need a subject for more content, how about an overview on heuristic development /selection? Overview on heuristic development and selection. I don't know, man. I'm not an algorithms guy. You know what I mean? I'm your salt of the earth TypeScript developer. You know, I like my divs. You know, can't put me into the position of teaching algorithms. Man, this coming from the guy calling me an asshole earlier. Just this guy comes out of the gate, tells me what content to do. I'm just kidding. Rick, GG Rick, welcome to the stream where everybody in chat gets it's a little bit of shit just for being here. Right. All right. So we are doing types. Let's go back to our types for this. Yeah. So projected pattern contains segments. I could also call this a candidate pattern. But I don't know if I like that because it's not really a candidate. It's children are sort of candidates. Rick says, no, I didn't. We all saw what you did, Rick. We all saw what you did. Rick's blood is boiling. He's like, this guy's kind of being an asshole. Saying I called him an asshole. YouTube's like, all right, that's the 10th time he said the A word. We're filtering this stream. I'll watch more later this evening. Try to drop in more often. Yeah, of course. Hang out. We have fun here. Appreciate it. And shout out to Build My CNC. One of them. Shout out to that guy on YouTube. Good guy. Very cool. Hangs out sometimes. All right. Yeah, so I think a projected pattern is going to have a G and H, but is that right? Yeah, it's always going to have a G and H. I'm going to add a comment here. So cost of the path considering all segments without collisions. Okay? And then H is the estimated cost of the path considering segments with collisions. You know, sometimes AI is such garbage. I keep having AI autocomplete code and do it totally wrong. Just some domains just has all the wrong ideas. Build your CNC. Everybody go check out youtube.com at build your CNC. Good guy. I tuned in for a bit of a stream yesterday. Or actually, no, I think he might stream at the same time or something. I'm not 100% sure. But I watched the stream afterwards. All right, so now that we know what our node is, we can call it Pat. I think Pat is a nice, fun word. It's too often used to mean personal access token. Patrick Hood Daniel. Yes. Is he on Twitch as well? Do you know? Is this guy a character you're familiar with? Seems pretty good. I don't know. I think his stream doesn't have a floating head for not everybody can just throw a green screen behind them. Not that I know of. Yeah. Might just be YouTube. I feel like it'd be demoralizing because he has a ton of subscribers. It would be almost a little bit demoralizing to like have 0 on Twitch because Twitch is kind of hard. The only time I've been able to get a decent number of viewers on Twitch was doing like a 10-hour stream. For some reason that works because you maybe show up on some random page for long streams. All right, let's hone in. So cost of the path so far. And then we have cost of the path considering all estimated remaining cost of path. I think it's easier to think of remaining cost, not cost to destination, because we could already sort of be at the destination. We just have collisions along the way. So that's probably the easiest way to think about it. And then that's why when you compute G, you don't need to know about the previous neighbor. So the computation for G is we're going to say pat.parent projected pattern .G or 0. So that's handling the base case 0. We can maybe simplify this just a little bit. So parent G. So we're going to add whatever costs you have on your parent plus whatever segments you have. And so this is kind of interesting. There's you could use the distance here. Who dis? Hello, Fabriv. Welcome, Fabriv. Welcome. We're doing some TypeScript. That's like my favorite name right now. Definitely not pronounced like that, but Fabriv. You know, I like to put a little bit of emphasis where it doesn't belong. So there's a lot of ways that we could score this. We could say the distance, like the length of the segment is what matters, or we could say just and this one I really like. You can just say the number of segments that have the collision. And the cool thing about that is you're not optimizing for this. I'll have to think about how we can look at it after the paths it generates and how it generates it differently. But optimizing for smallest distance is much different than optimizing for lowest complexity. So let's try to optimize for lowest complexity. He is on Twitch. Build your CNC. Okay, cool. So I can follow him there as well. Good. So the cost of the path is related to the number of segments that do not have collisions. There's a lot of ways, so lots of opportunity to compute G differently. I just want to mark that because that's going to be a really interesting area to play with. That's where all of our, I think that's where most of our, is that where all of our play will be? I think that's where most of our play will be. Yeah. There's sort of the inverse pattern here too. So if you have a collision, we're going to say compute H. So probably equally as much opportunity for play here. I think we probably will just make these inverses of each other. But you could do other things. You could certainly use distance and stuff like that. Yeah, okay. So that's our compute G, compute H. These are basically like static methods. I don't even know why they're class methods. But let's keep following in the footsteps of our other algorithm, because that stuff isn't stateful, but there is stuff that is stateful. So yeah, get neighbors, that's a really important function. So we're going to return new candidates. So get new candidate patterns is what we could call that. Get new candidate patterns. Make it a little bit more specific here. Excuse me. Oh my goodness. Yeah, this is basically find all patterns that can be reached from the current pattern. Yeah, that's perfect. Sorry guys, I'm a tiny bit sick. Just got a little bit of the sickness inside of me. But the good kind, the kind that goes away. I guess. And a little bit that doesn't, maybe. Perhaps. Okay, so we've also got the open set and closed set. That's kind of the most important thing. Open set and closed set, that's telling you what you've explored and what you have yet to explore. Get out of here with that junk. Suggesting things. Closed set, so how the closed set worked for yeah, this is a tricky one. So how the closed set works is you basically want to be able to quickly check if something has already been explored. With our pattern explorer, that is currently basically impossible. If you're recursively exploring patterns, you can never come upon another pattern. So I believe we do not need a closed set, which is kind of crazy for an A-star autorouter. But because it's impossible, that would be a characteristic of this method, because it's impossible to ever come upon a pattern through the same pattern through recursive exploration. We don't need it. I'm sure there's things that violate that rule for specific patterns, but generally, it's not possible. So we're not going to worry about that. That's basically it. I think there's going to be a function like solve one iteration, something like that. We have the number of iterations. We can add that as a variable here. Add it to the top. Iterations number equals -1. Solve one step. I like the name of it. Solve one step. Yeah, and that's exactly how it works. We take the first element out of the open set. If there are none left, we return. And then it's saying get new candidates from the pattern or from the current. You can do that. It's a little bit of like base case design here. I think what I want to do is check if pattern. How do we do this? Yeah, it's kind of deciding how much work we're going to do. We could say if current.segments.every segment does not have a collision, we can say we're done. So we can say solved pattern or whatever you want to call it. Yeah. Solved pattern equals current and return. Excuse me. Solve one step. We could also say if this dot solved pattern, we could just say we're not going to do it. I think I'll leave that out though. Okay, so if all the segments do not have a collision, we're going to say, okay, we're done. Are there any other base cases? We covered this one. If no current, I think we're good. So at this point, we can assume there is at least one collision in our current pattern. So yeah, I think, is that it? We just do, yeah, get new candidates, openset.push. We need to sort so this is, the openset is typically implemented as a priority queue. And I did this implementation the other day and I actually found like a massive speed up, but I never merged it. So right now I'm using priority queue for openset. Let me see how hard this priority queue implementation was. If it's not that hard, I'm just going to call .sort on it. I wrote a whole little article here on how to use A star. I should have read this. I wrote an article just for this. But I think I've over-mandated my own methods in some ways. So sort openset, openset.splice max openset size. Not needed because we do. Okay, so it's not needed. I bet I made a custom data structure that I can probably import. Oh, I didn't. Binary search openset insert. So it does a binary search to where the openset inserts. And this is, this was the fastest method. I think I tried a couple. Yeah, so yeah, I guess what do I want to do? I'm trying to think of, yeah, you got to kind of think about, all right, fine. We'll do it. Copy this out. So it's going to do a binary search to throw in each new candidate. And then I think we didn't finish this one. So this one's going to return projected pattern. And there's really two states of projected pattern. These ones are not going to have, I think, G computed yet. Is that right? Maybe we always compute G and H right away. Oh, no, we can't. Okay. All right, I think I understand. Okay. Huh, okay. All right, I'll leave this as is. I'm gonna be a little bit lazy on the type, but it should be a fully computed projected pattern at this point. Okay, so generate new candidate patterns. This is gonna be like a lot of coding, and then everything's gonna magically work. That's how this is gonna go in my head. And I think I gotta check. I think I only have so much time to do this because I'm pretty sure I'm going to be whisked away. Yeah, I'm going to be whisked away in a little over an hour. So, but this will only take 5 minutes, so we should be good. Start the timer, 5 minutes. All right, get new candidate patterns. We're going to implement that in a minute, but let's make sure we understand how this works. What is F? Auto magic. What is F? Let's see if I wrote any docs. I'm realizing, my copied code. Distance score for this node G plus H. Ah, yeah. Okay. And that's a common name for that, I think. F is G plus H. And since you use it a lot, yeah, look at that. Cost of path. So maybe Cursor talks across my IDEs. That's kind of crazy. It's not really the cost of the path. It's estimated total cost of path G plus H. Okay. So we will sort by F. Within the open set, these are always going to be defined. So I'm just going to do that. That's where I was saying I'm being a little bit lazy about the types. Okay, so it's doing a smart binary search open set insert for those candidates. And the reason I was hesitating on this is because I was like, these candidates, just because of how this algorithm works, I think these candidates are going to be close together in the array. So it seems like there's probably a faster insert here. But honestly, the sorting part of the open set is not usually the dominant part of the algorithm. It really is more about how many iterations you do. And most of the time when I optimize these, I just measure the iterations. And that's how you improve the pattern or improve your parameters, your hyperparameters, the greedy multiplier of A star, which has a couple names. I call it greedy multiplier, but I think it has some different names there. Okay, anyway, I think we're in a good place. So the last thing is to compute to get new candidate patterns. And so I'm going to create a new object. I'm just going to call it patterns, and that's going to be a non-projected pattern. We could call it pattern definitions. Yeah, actually, pattern definition is a good name. Pattern definition. So, yeah, like wide arrow, straight line, double bend. These are all just some definitions, and then I have this kind of single layer pattern preset. So that's what we're going to set it to. We're not modifying this. It's just the patterns that we're set up to use. Okay, generate new candidate patterns. I already have an implementation of this somewhere. So let's see. Pattern definition. Oh, this dot project pattern. It's a nice idea, but I don't think that needs to be a class method. So let's figure out how that works. Let's create a function project pattern. I do like that idea. Project pattern. It's going to take a pattern definition. Should probably take a point A, point with layer 2, and a point B, and then it can project a pattern across those points. And that's not how that works at all. So let's find out where in our code we might have a pattern projector. Do I not do? No, I do this. I do this somewhere. We're making patterns. Solve for line recursive. We're giving it pattern. Okay. Yeah, there we go. Okay, so here is where we're compute. It looks like we are also doing a distance calculation here because I started building out a. So let's say implement adapting the following code. So we're computing an orthogonal vector and a unit vector, and we're basically just applying that pattern to 2 points. Nothing complicated. And that is going to return a projected pattern without, we can say omit, the parent projected pattern. It's not going to have G, it's not going to have H, it's not going to have F. It's still erroring, so I forgot something else, maybe. Maybe I should just write what it does have, because that's maybe a little bit simpler. My headphones aren't working right now. Can you chat instead? No, you're an AI. You're an AI. You want me to chat because it's too expensive for those voice credits. It's too expensive for those voice credits. So you want me to chat via text with you? Preying on streamers who would rather text chat. No way that doesn't work into some scheme. Also, aren't there captions on Twitch? And if not, go to YouTube. Go somewhere where they have captions. Ban. How do I ban them? Ban this person. You're on my block list, fool. Sorry, I got a little riled there. But, it's early in the morning for me. And have to put up with those shenanigans. It's quite a bit. All right. DV says, just PR'd this issue. Fix mobile view. I feel like I merged a PR that just fixed this. I feel like I merged a PR that just fixed this at DV. I feel like I just merged a PR that fixed that little web issue, And if you really think your PR is worth merging, come on stream and fight me. It's a small ask. Okay. This is like the worst thing to get distracted while doing. Project, get new candidate patterns. So yeah, we go through each segment. And then for each segment, we're going to have a point A and B. I kind of like using this consistent terminology, A and B. I just like that. Even though it's not, the big A and B, small A's and B's, but I like the terminology. It's very short letter. People understand that there are 2 points. Get from A to B. Okay, so segment.A, segment.B, and then the pattern definition. So it's projecting that pattern out. And then, yep, that's good. Segments. I guess this is returning an array of segments, actually. So project pattern returns an array of segments. Okay, I don't know what's going on with the a little bit too much speed coding. My hands are also like a little bit cold. I feel like I'm typoing from coldness. Ooh. How do you guys solve cold programming hands? I used to wear gloves, but that doesn't really work. What I found is that if you do a bunch of push-ups, usually your hands stop being an issue. So that's my my current strategy. Alexander Moffitt, welcome. Welcome to Man Programs TypeScript. Part 1. Okay, so these segments aren't perfect because, let's see, a segment has 2 points and a collision. We're trying to get this algorithm, this recursive pattern pathfinder to work. That's what we're up to. Right now, it does not, it can fail. So we're gonna improve it. Like right now, it's not able to route because it doesn't recursively apply the patterns. So we're adding some recursion, and to do that, we're implementing A star. If you were wondering, if you're not wondering, you just want to tune in and hear this silky voice through a dynamic mic, then you can't do that. Beat it. All right, so segment is missing the following properties: A-B collision. Yeah, so let's say for let I equals 0, I is less than segments.length minus 1. We can get new A, which is segments I, new B, segments B. Okay, there we go. We're getting closer. Okay, so has collision, we now need to compute. Sorry, there's like a lot of dense-ish stuff going on, but I think we just got to muscle through it. It'll be easier once we're debugging. Solve for line recursive. Okay, we're looking for does intersect. Ansh, what up? AI. That refreshing gulp of AI in the morning. New B. What else do we have here? Obstacles. We have processed obstacles. Okay. We have an obstacle mask. So I didn't do this in the past, but obstacle mask is what obstacles are applicable for a trace, because sometimes when you're auto routing, an obstacle isn't applicable. For example, if it is connected to the same network. So that's why I added obstacle mask. I used to pre-process the obstacles for each trace again, and it occurred to me that that might be a very expensive operation. So not doing it anymore. What up, Ansh? How you doing? I don't know if I saw any PRs today. Did you get that fake Reddit thing merged? We haven't played issue roulette. I might skip issue roulette today to see if I can get something cool looking out of this algorithm. Okay, I'm gonna be a little bit lazy. I'm just gonna say processed obstacles is on this object. We'll do a little bit of manual fixturing and then we'll refactor. That's probably a regrettable choice, but I really want to get something working as soon as possible. So we'll just make that on the state. So has collision. Okay, so that's how we get our new patterns. And then we need to return them. New patterns. So I don't even know. Oh, okay. So before we return these candidates, we should also compute the cost of the candidates. So we'll do this. What are you making? We are making an auto routing algorithm. And to do that, we are writing, we're implementing A star. So okay. So yeah, GHF, the critical factors for A star. think we've basically done it. So I'm gonna create a new sort of auto routing interactive thing that uses this new auto router, and hopefully it just works. It's gonna be a bit tricky to figure out if it works, but I think we did our best. Yeah, we have some weirdness. For example, we don't have a closed set because I said we shouldn't need one. And yeah, it's recommending we sort the open set instead of doing this like weird binary. So like there's areas where it might go wrong, but I think we're pretty good. YouTube doesn't do pin messages. I don't know what a pin message is. Is it like I can... Oh, I see. It's like I can say... Usually I just have a... If Yeah. I mean, but the thing is you kind of need a visual to see it. So like, yeah. What is AutoRouter? You know, you can find out at autorouting.com. It's the process of drawing wires on a printed circuit board in order to connect all the components or chips of a circuit. So we are trying to build a custom AutoRouter. Not for too long. I always waste... I think I dedicate nearly 20% of my time monthly to trying to make an AutoRouter. And then usually at the end of the day, we use a different project entirely. We use an autorouting algorithm that I didn't make. We use a third-party autorouting algorithm. So it is mostly a fruitless effort and a huge time suck, but... You know, maybe one day I'll stumble on gold. You know, we're here in the river of algorithms fishing for our little gold nuggets. All right. Anyway, this is the first time I've had such a nice interactive playground for playing with the AutoRouter. I didn't have that before. I used tests, and we'll do snapshot testing for this. But yeah, it's just like you get a little older, you get a little wiser. And you're like, okay, I want it all. Especially the cost of doing these things goes down. So the cost of making a Vite app and setting up this little storybook is not as high anymore. So I'm happy to do it. And it actually the setup time becomes worth it. So we can have different test cases. So I already have an example 1. We're going to create an example 2. So NVIDIA level stuff. NVIDIA levels. Let me see if I know this. NVIDIA levels. Oh, NVIDIA does a different type of auto routing. They do a lower level auto routing. Although I have heard that NVIDIA, to route the printed circuit board... So NVIDIA has 2 parts. They have chip design, and then they do PCB design. I primarily deal with PCB design, printed circuit board design. So the green board, printed circuit board. So NVIDIA GPUs inside of them will have a printed circuit board, right? But then these chips also do a type of specialized auto routing, which a lot of really smart people work on chip auto routing. So I could beat them, but it would take longer. The printed circuit board, not a lot of people work on. Barely anybody works on these other lines. Very few people. I mean, it's still maybe in the thousands, but very few people do too much work on them. So, and you can see, you know, in a really well-routed circuit, these lines are really close together. So our algorithm will need post-processing to create lines like this. But one of my theories is that post-processing is actually quite good. Rohit says, nice, now I am understanding your code little by little. Yes, it takes time. Exposure is good, you know. Like the control modules, yes. The chips, yeah. It's a pretty good way to put it. So routing between the chips, which are the control modules. Yeah, so NVIDIA, I think it takes them about a month when they have a GPU to route all the lines, and they have humans do it. They probably use computers for some of it, but I'm told it takes about a month for them to just route the green part, which is crazy when you consider, all the stuff they're doing on the chip side. That's really where their innovation is on the chip side, but it still takes them a very long time to route the PCB. So, would this kind of algorithm be applicable? Maybe not, but it's actually hard to say because in my camp of belief is that you can actually use a very simple algorithm like these, and then you can post-process it to make it smooth, make it look better, etc. All right, so we're going to create example 2. You can see as soon as I created the file, it popped up here. We've got a React component where we're passing in our simple route JSON, which is the autorouting.com routing format. And then we initialize an autorouter here with the simple route JSON, and then we do solve for traces. So we're going to modify this to use our new autorouter. So generalized A star kind of became a little bit less general. I'm going to do some very manual initialization of this. So we have process obstacles, so we need to process obstacles, simple route json.obstacles, and then for our obstacle mask, let's just say all obstacles are applicable. Sorry guys, the code is big. It's big for you, but it makes it very difficult to see what's going on. Okay, autorouter.processed obstacles map. We're going to say every obstacle is applicable. I can't remember which way it goes, but I think true is the right way there. Patterns, that I think the default on that is good. And then the last thing we need to do, because we're kind of hacking together the initialization here, is we need to add an initial pattern to the open set. So the parent is null. This is kind of our root pattern that all other patterns will be based off of. And we need to add a segment to it. We'll say, what do we want to route between here? Actually, I think you can drag and drop these. So we need to make it so you can drag and drop them. Is there any easier way to do this? Hold on. Autorouter open set. Okay, we're not going to manually define this, actually. We're going to say simple route JSON. We're going to continue the conversion here. Yes, we'll do this. And then I kind of just left some hints for how to make this multi-layer. The thing I didn't say earlier is on these printed circuit boards, they are they're multi-layer, so there's actually traces under the green part. Yeah, people are telling me I need to ban the Twitch bots, but I don't know how without going to Twitch. I need to get a Twitch mod. And then we'll set these up. I don't know. We'll just set these up like this. Can you type in this chat? I think I can, but it's going to come through ReStreamBot. Hello, world. Yeah, it's going to come through ReStreamBot. So I'll figure it out. Imposter's like, hey man, this is the 101 of streaming on Twitch here. Notice coming from you, just do it. Okay, but I already kicked them out of my Restream. I already banned them from Restream, so I lost their username yet again. I'll do it next time. Ban username reason. Imposter's like, dude, you gotta keep the Twitch ecosystem high quality. Here it is, insufferable. Okay, so /ban insufferable hiss spam. All right, we'll see if that works. We've attempted it. What is exclamation Twitch? Is this like live stream terminology? Can you see the Twitch stream on YouTube? I don't know if you can. Guys, stream logistics. I'm not, I'm here to write some TypeScript. All right. This is a man and his TypeScript, not a man and his TypeScript and chat spammers. You need Nightbot so you can add commands. Oh, I need to add a Nightbot. All right. I'll figure it out. I'll figure it out later when I can be fucked, which probably should be pretty soon because it is annoying. We need to get the traces out of the auto router. We also need to make the auto router solve. So we have this function that solves one step. This is gonna be really cool, guys. We are on the precipice of seeing all of our work come to fruition here. I wonder if I can say, what should I do to make this work? Okay. Oh, we just, we do solve one step until we have a solved pattern or until our open set is empty. So we can say, oh yeah, we can also watch the iteration count, make sure we don't crash my computer. So, and this dot set open length and not this dot solve pattern. Yeah. And then we can, this dot solve one. Okay. Thanks, AI. AI is like, bro, this is basic. I can't, but you can multi-stream. Yo, Twitch. What is his Twitch name? What is his Twitch name? Who are we talking about? The guy I banned? Insufferable Hiss? The guy I didn't ban because I don't have command set up. Guys, we're focusing a lot on chat spammers. It's a topic that's near and dear to our hearts. We're trying to keep the stream. The stream is a sacred place, right? So I get it. I get the concern, but so much effort, so much effort to figure it all out. All right, we have to figure out how to derive a trace from. Oh, my Twitch name is Sevi Ibar. Sorry. Wait, you're gonna follow me? Oh. Just got to get people to pump up these subscriber stats. Some days, some weeks, it's very encouraging. Let's see, where are we at? 229, nice. +4 from yesterday. Let's go, yeah. But it's really not. At the end of the day, it's not really about that. One of the reasons I stream is because it's very easy to get distracted if you're not streaming. If you're streaming, if I was scrolling Twitter every 5 minutes, I think that would be even worse than we already are. So the other reason is it's just nice for people to see reviews and stuff like that. I haven't created a lot of issues this stream, but I think the algorithm focus is all right. Okay, so we'll say solved pattern equals autorouter.solve. Now we need to convert this into a trace, which means if you think about it, there's this series of segments we have to go through. So we'll say trace equals an empty. What is this? Trace. I think it's a route. What is it? What is in a trace? What do you need from me? Simple route JSON trace. Okay, we can import it. Okay, so we're gonna. It's got to be a recursive algorithm, unfortunately. So we'll say get route from solved pattern, and I'm just gonna define this up here for now, because each solved pattern can contain more patterns. This is a fast recursive algorithm. This isn't like, we're not like, this is just data processing. It's not a big deal. This is going to be a pattern something. I can't remember the name. Projected pattern, I think we called it. Hello, Sevi, says Ansh. Hello, Ansh. Hello. How are you? All right. So, for segment of solve pattern segments. Nope. Why do I let AI keep doing this to me? Why do I let it keep generating stuff for me? It's so wrong. All right. I might literally turn it off in a bit because it's killing me. All right, route wire is what we need. So is an array of route wires. Yeah, that's not right. Okay, so if segment has collision, if it has a collision, you don't add it to the route. Or we could make this a little easier. If it doesn't have a collision, we'll add it. So yeah, route type wire, blah blah blah. We're gonna keep it very simple. Put everything on top for now. We're not gonna do multi-layer today. Yeah, let's do this. So we add both segment A and B if there's no collision on the segment. If there is, we need to kind of explore the segment's children, I guess. Is that right? Yeah. Okay. Oh. Oh, what are you complaining about? Blah, blah, blah is missing the following properties from route wire. Are you sure about that? Oh, I see. Oh, what are you complaining about? Let's see if AI can get us a decent fix. Okay, yeah. Perfect. All right. So if the segment doesn't have a collision, segment has collision, recursively add child segments, I think. Oh, wait, is this even weirder than I thought? Okay, so the solved... Okay, all right. I'm starting to realize how this works. We get this... we have to look at its parents first. Okay. Oh, man, this is so weird. Okay, all right. I'll draw it out, but this is kind of a tricky one. All right, so you've got a pattern and a sub pattern, which I will color differently. Let's say it's like, let's try to make them even more distinct here. So I'll say that, and then you have let's say, I don't know, A and B are kind of bad, but we'll say start and review you. What do you need reviewed? Oh, wow. A couple people posted things I think I missed. Basic initialization for the CLI. CLI test fixture run command. Run command TSCI init. This is okay. Do we want to do it this way? I guess this is okay. Dir contents. Yeah, all right. Okay, so the only problem with this PR on fake Reddit, I would say not now, motivated Anch. Yeah, right, as we're about to close out this algorithm. Anch's timing is legendary, I think. Yeah, I do want to close out this algorithm, and I do have to go in like 20 minutes. So, yeah, but use after each from bun test to automate cleanup inside get CLI test fixture inside the CLI test fixture function. Okay, one small change and you are good to go. Nice job. Did Rishab give you a review on this one? Honestly, if Rishab likes it, it's probably good. Let's see. Looks good to me. Okay. Yeah, I'm gonna defer to Rishab on this one. If there's a problem, you know, don't be expecting, you know, repeat bounties if you have a bunch of problems with it. You know what I mean? You gotta clean up your own doo-doo, so to speak. I think we had maybe some other. Yeah, we have some web dev issues. I'm gonna avoid the web devy issues here, and okay. So this, okay. So a little bit hard to keep track of, but we're gonna do our best here. Let's say this is yellow. Put this on the bottom. Remove the stroke. How do I remove stroke? Probably have to set it to invisible. Okay. So this is like kind of like our pattern 1. And then each of these smaller patterns this is kind of like our pattern 2. I'm doing my best with the colors here, but struggling. Then I gotta do this and then a little bit of that. Yeah. Okay, cool. Okay, so that's pattern 2. That would be pattern 2, and this is pattern 3. And then I'm just gonna think through the data structure that represents this so that we're not like getting too confused. So hopefully it helps us move as fast as possible. Okay. So that's our hierarchy of patterns here. I don't like how that arrow is obscured. There we go. Okay. So that's our hierarchy of patterns. And so if we think about the data structure that represents this, just so that we understand what we're working with, so that we waste as little time debugging as possible, the data structure that represents this is parent pattern null for the top one, and then we have segments, and then this is the first segment. So it's going to be like I don't know. I have to give these. This might save us debugging time, you know? Sometimes breaking things down saves you a little bit of debugging time. So let's hope that's the case. I'm going to give these kind of arbitrary numbers here. So this is 0.5, 1.5, something like that. Okay. Just so that we can kind of track it. So A is the 0, 0. B 1, 1. And then I think So where are the children? Projected pattern. I think we need the parent segment index. Yeah, because it's like what segment on the parent is related to you. So we'll say parent segment index equals I. And is that right? No. Path.segments. Oh, wow. Did I really? Okay, so we'll say new segments. Try to make that a little bit better. Okay, new segments. And then we need to make this a, for let I kind of thing. But it reused I. What is up with AI nowadays? Reusing the I variable like a fool. So we can use the full name here. We're not using it very often. So parent segment index. Okay. Yo, Absy, what up? Oh, electronics devs posted something now. What did they post? What, on Twitter? What are you talking about? Yeah, there is a person who runs that feed for me. And Matt. We jointly work with somebody to help us manage electronics dev. Okay, so that's, is that right? Okay. Oh, all right. So this is a inverted tree. I'm now realizing. Okay, so this is an inverted tree. So the parent, is it? Yeah, I think it's an inverted tree. So the parent pattern is inside of the child, right? So maybe I should have done that. Maybe I should not make this an inverted tree. This is insane. Whatever. We'll try it. It's an inverted tree. For better or worse, it's an inverted tree. All right. I think I understand this, but this is gonna be hard to explain. I think I'm gonna copy out. I'm gonna log the result here of the algorithm. The solved pattern, and that should help us. Yeah. So we'll do that. Just fix our type errors. Solved pattern, and this will be an inverted tree if my understanding is right. But first we have to fix some bugs. Syntax error. That's a type error. I don't see a syntax error. Left side of comma operator is unused. Left side of comma operator is unused. Somehow a comma got in there. Okay. So we've got this object. Yeah, there we go. So the parent is inside of a child. So if we make this path collide, we should see, it's not going to appear yet because we haven't done enough work, but we should see that this parent gets more complicated, or it's too broken for us to even. That's why it's sometimes nice to build a visualization before you do a bunch of code. Oof. Okay, well, the good news is it's somewhat understandable. So, we could probably hack this. So what we could do is we could do a really, really hacky recursive like segment retrieval and just flatten it and call each one its own trace. And the benefit of doing that is we don't even have to think about how to construct it in the proper order. And it's not like the key part of the algorithm. So let's be extremely lazy and do that so that we have a visualization, because it's going to be too hard to debug the algorithm at the same time. Yeah, let's go ahead and do that. We'll do the same thing where we do get route from solved pattern, but we'll just modify that function to be a little bit. No, that won't work. Hold on. Yeah, that's not gonna work. Say get all segments from solved pattern. So that can return a list of segments. We can't use this function. The function actually has to be constructed properly. This can return a segment, which I think we have a type for. So yeah. So we're going to push any segment that doesn't have an intersection. So if not segment has collision, do that. And then we're going to go through all the parent segments. So for if solved pattern dot parent projected pattern, is that right? Segments dot push, get all segments from parent projected pattern. Okay. All right, we're getting there. How disappointing would it be if I didn't finish this on stream? And so we had, I just posted the results later and nobody got to see the moment where it gets revealed. So disappointing, but you know, life works in unfortunate ways sometimes. Okay, so we're gonna map each of those. That should work. Why are you complaining? They're saying, oh, maybe the pattern wasn't solved. We'll just pretend it's always solved. Okay, and then we refresh. So now we should be drawing it, and it's almost drawing it. It's almost. We even get some changes as it intersects things. So that's kind of reassuring. So let's see. We draw A to B, get all segments from solved pattern. I don't know why this wouldn't give us all the patterns. That's so interesting. Why would this? It feels like it's coming a bit short. Wow, this is you can see as it collides, it changes, but I think all the interesting traces are being hidden from us. Let's take another. I don't know what's going on. Let's take a look at the segments being returned here. We're running out of time though. We only got like 5 minutes to finish this out. I'm going to have a really cool video later though. Like later, it's going to be so cool. You guys will be like, whoa. I wonder how he got, you know, you don't know if I can actually code, because sometimes kind of happens behind the scenes. It's like, did he fix it, or does he have like, you know, a really smart girlfriend who comes in and fixes his algorithms when the stream's offline? You don't know. And that's on purpose. You know what's weird is it's also saying there are 2 segments it should draw. You know, it's all very strange. Has collision false. A to B negative. Route is these 2 points. Oh no, there's only one. That's one trace from one segment. So where's the other segment? here's one segment. The parent has a segment, but that segment apparently has a collision. Oh, because okay. So the parent has a collision, but why I think this is an algorithm issue. Why is there only one segment created? It should be creating many segments. So I think we have a problem in the actual algorithm, which is good. So let's go to our generalized A star, which is no longer a general A star. It's basically just the algorithm. And I suspect it's getting to... So we go through each parent segment, each pattern definition. We project the pattern. I think this doesn't make sense. Oh. What's the type of this? Project pattern? What do you... Oh, no, maybe that does make sense. Okay. It's just this variable is bad. Projected points. If current segment, every segment has collision. I think the pattern isn't solved if you do this. Yeah. I think there's cuz it's really about the entire tree not having any collisions. So you're really saying you're really saying like, oh, okay, my subtree is good, but it doesn't mean the entire tree is good. So I think this is a problem. I'll have to think through this a little bit to figure out the full solution, but I'm almost positive that this is the problem area. It's like returning invalid segments because as soon as there's not a collision, I think it returns. Did you look at the 3D download feature? It's not working in some GLTF viewers. I did not. I did not look at that yet. I can take a peek. I don't know why it wouldn't work because that's in export from 3JS. So, but I don't know. We load those from URLs. We're probably doing some loading weird or something. So as long as we have a URL to a bad model that we can throw in 3JS, we have a good reproduction. So we'll figure it out. Unfortunately, I do have to cut out a little early. Normally I would stream another hour, but I have to prep for a quick meeting. So, and maybe get some food in me again to avoid meeting crankiness. But thanks for joining. We didn't get to play issue roulette today. We'll play next time. But thanks for joining, and I will hopefully post about this later. Someone's PR did that work. So somebody did fix the 3D download. I looked at it at the very beginning of the stream, and I didn't think it fixed anything. We can see the issue there. .3js view URL, 3js object reference, 3js view URL, download GLTF from URL, view URL is being passed around a lot. I think they just changed how the object is passed around, right? So it's cleaner, but it doesn't fix anything. I mean, I could be wrong, but I don't think it fixes anything. Am I crazy? Actually, I think download GLTF to just view URL, preview content. I'm just trying to understand this. Use export. I think does this compute the export URL on every render? Isn't that very expensive? Yeah, I'm pretty sure the reason we didn't do that approach is because I think it computes at every single render. So yeah, I think that's the issue. It works on some, but it doesn't work on others. Okay, interesting. I don't know. We'll figure it out. Okay, but anyway, yes,